This is the video for Mod 12 Lesson 3, Chords in Circles. The goal of this lesson is going to be using properties of chords, and those are segments in a circle where the endpoints are on the circle, and we're going to use that to find different lengths within the circle. So a couple of theorems we're going to see pop up here. One is talking about if a chord is a perpendicular bisector of the other, that makes the diameter. So we might see that property come up a little bit. But the big property we're going to see is that when we're talking about two chords that are congruent. So when we talk about finding the distance or the length, or when we say they're equidistant from the center, we talk about from the center to the middle of the chord, and it makes a right angle when we go to the midpoint of the chord. So when we talk about the distance, that perpendicular distance is making a right angle. We're going to see that property come up today, and we're also going to see that when we draw radii for these problems, they're going to create right triangles, and we're going to be able to utilize a lot of our strategies for solving with right triangles. So the first example we're going to see, it says find the length of the radius if HK is 30 and PM is 8. So the first thing we have to do is label our diagram out. We see that HK is this segment right here, and they're saying that this is 30. What we also see, though, using the diagram, is that we have this these two distances that are the same, and they create right angles. So we can use our property of that this is actually a perpendicular bisector, and HK is actually being cut in half. These are both 15. So HN is 15 and NK is 15. We also can see that these distances are the same, so they tell us PM is 8. Which also means PN is also 8. Okay, so we have we actually used a few of those two properties we just saw. We actually used them just now in the same diagram. So we have these two lengths, two chords essentially that are the same length, and the goal is to find the radius. We do have a radius in this picture. It's actually, you can see HP is a radius. And we can see HP as a radius, and we actually have a right triangle here. So if I was to redraw this a little bit larger, you can see this is P, this is N, this is H. This is our radius, which we're trying to find. And then we have that this is 15. And this is 8. With a lot of these problems, the radius is going to act like the hypotenuse. So we're going to go ahead now and just do Pythagorean theorem. So you could see r is on a side by itself, 8 squared plus 15 squared, and then we're going to go ahead and solve this out. So we go ahead and solve this. We're going to get 289. And r is going to be 17, and we didn't have units here, so just 17 units. So the radius is going to be 17, and we just used Pythagorean theorem. In this next example, it's a very similar problem. The first thing we have to do, though, is label our diagram. So they tell us here that AB is 8. If I look at AB is a chord, and you can see it's got that right angle being formed with a segment coming from the center. So I know that this is getting cut in half. These are both 4. And then they also tell us DE is 8. Sorry, so this is also 8. And again, same concept, right? So these are both 4. So since these chords are actually the same length, we do know that their distance from the center is also the same. So I know that whatever CG is, CF has to probably be the same. And then they do tell us that CD is 5. CD is your radius. And the goal is to find what CF is. So CF, I don't know what it is. So we can do a few different things here. We could either draw a new radius, knowing that this is going to be 5, and you can solve with Pythagorean theorem, or we can solve the triangle we already have with Pythagorean theorem and just know that CG and CF are the same. It's going to end up being the same thing. So my hypotenuse, they tell us, is 5. So I'm going to do 5 squared equals 4 squared plus x squared. And just go ahead and solve it out. So we have our right triangle. And I'm going to do the square root. And we actually get our answer to be 3. So CF is going to be 3 units long. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.